I will be going through this webinar, Embedded Linux. This will be the contents. So I will introduce first about the field that is embedded Linux, and then what are the current trends in the market at present situations with respect to the jobs, how the industries are flowing, and what is need of at present situation embedded Linux in the market. Then we will see actually what is exactly embedded Linux. Okay, what are the leading embedded Linuxes are available at present situation in the market. Then we will go through the typical job role that any embedded Linux engineer would need to have. And at the end, we will go through the how we can get into this domain. So what is in general embedded system? So just before moving actually in Linux-based embedded system and the concepts of the embedded Linux, let's try to understand what is exactly embedded system. So in general, if you take any embedded system, then we have a unit called as central processing unit. We call it as a CPU, right? We have the input devices connected to it in order to get some kind of input. We have the output devices in order to show the output, whichever we have processed by using the CPU. And also we must have a read-only memory ROM. We must have the random access memory RAM, and there could be some circuitry which is application specific, and there could be some kind of communication interface such as Wi-Fi, Bluetooth, or BLE mesh or LoRaWAN, right? So in general, if you take any embedded system, any embedded product, then predominantly we will find these blocks. If you see the types of embedded system based on the performance, then you can see the small scale, medium scale, or sophisticated embedded system. And if you see from the functional requirement, then we can see a real-time operating system based embedded system. Then you can see you can have the standalone embedded system. Then you can have the network embedded system, or you can have the mobile embedded system. There is another categorization of the embedded system, and which could be based on whether it is the microcontroller based embedded system or whether it is the Linux based embedded system, that is the microprocessor based embedded system. So let's take an example where many of us must have used this product, right? Mouse, right? So here, if you open up the mouse, then you can see what are the components present inside the mouse. Yes, definitely we'll have the microcontroller inside it. We have the scrolling wheel, which acts as an input device, right? We have connect, which is our PC. We can say it as output line. And then we have the small microcontroller inside it. And registers, LED, capacitors, right? So we can say it as a supporting circuitry. Right, so this is the microcontroller-based embedded system where we have the microcontroller inside it, and here the application would be we have the constant source of input, that is the movement, whether I need to move it from the X direction or in Y direction in so much centimeter or millimeter. That need to be get converted. That would be given to the microcontroller, and the microcontroller executes some kind of action on it, and we get the output which need to be transmitted in the form of electrical signal to the mouse. And the movement we would see, the equivalent movement we would see on our screen. So you can imagine the microcontroller is predominantly used here, which is a very low cost, and it is having the dedicated task. So for example, it is having the dedicated task of just movement according to the wheel. Nowadays, optical sensors are coming. So based on that movement, I need to get some dedicated input and I have the dedicated out. So for that, I don't need a general purpose processor where I need a multiple task where the many tasks are being executed at the same time. So it's very simple. I have the constant input that is dedicated input. At this situation, I have only one input. I'm processing it and I'm just giving it to the USB wire to the my computer. So this is unlike our mobile phone. So our mobile phone consists of the microprocessor. If you go for purchasing microprocessor, then you ask vendor many details. You ask what kind of processor it is. You ask whether it is having how much GB of RAM it is having, how much GB of ROM it is having. That is the internal capacity, how much external it can provide. And as compared to the mouse, you can see we can have the n number of input which is coming to our smartphone. Right? It can be some input which is coming from the camera, some input which is coming from our cellular network, some input which is coming from the on-off button. So if we try to use the microcontroller-based system where the number of inputs which is coming to the microprocessors are not constant. Moreover, the combination, if you see that if you are taking a call and simultaneously you can see some kind of other PDF opened in your mobile phone. So we can differentiate between the microcontroller and microprocessor based system based on whether we have the dedicated number of inputs and whether the nature of the inputs that we are getting processed, whether that is in the static nature or it is in dynamic nature. Right. So we can categorize the system as a microcontroller based system and the Linux microprocessor based system based on predominantly on these factors. Of course, there are other factors, but I'm just taking from the number of input perspectives and how we are dealing with those inputs. So when we come to the microprocessor based system, then definitely we need some kind of operating system running on that. So can we install Windows operating system on and can we run it? No, we can't, because it's proprietary, and the limitation of that is if you purchase the Windows operating system, then again we can't customize it as per our requirement. So in order to have the flexibility, in order to communicate with the external devices, external input, in case of this smartphone, we need to communicate with the external sensors, we need to communicate with the camera, we need to communicate with the screen, right? So all this customization is possible in the Linux, right? So as we've seen that, like here, we can see that microcontroller based system, which I just explained, where we have the input as the displacement measurement sensors. For example, we can say wheel. To take the input, sense the displacement, the screen movement calculation is taken place at the microcontroller. Then sending the signal to the computer via USB or the Bluetooth interface and display it on the screen, right? So this is the microcontroller based system. And here we need hardly some KB of memory, ROM memory as well as RAM memory. Here we can say the external additional circuitry we need is LED device to LED, some kind of LED in order to just display whether it is on or off, or we need on-off switch for that, or we need some kind of interfaces. In case of this, we have the USB or Bluetooth interfaces. So if you go to the microprocessor-based system, predominantly we say it as a Linux-based microprocessor-based system, then for example, in case of smartphone, we have the touch screen as an input, right? We have the same screen of the computer or the same screen of the smartphone in order to display the output that we are processing. Here we might have the memory size in GB. Here we might have another circuitry as different sensors. For instance, I've just taken an example as on-off button. And here we can have the many interfaces in order to communicate with the external world, that is USB, Bluetooth, Wi-Fi, GPS, and the cellular interface, right? So if we see the architecture of embedded Linux, which is running on predominantly on the microprocessor, which could have the user interfaces or the services, which is running continuously on the middleware and the application. Right, and then it comes operating system where the user, the calls or the some kind of actions would be handled by the operating system, and this is passed on the board support package or the drivers, and ultimately it is given it to the hardware. So to just take an example of our smartphones, whatever the app we have installed, right, that is, we can say, as a user interface, which is installed on the top of our operating system. So what does our mobile phone consist of? It consists of the Android operating system, which is derived from the Linux kernel, or we can say, for simplicity, Linux operating system. So we can say this part constituted of the Android operating system, right? And whatever our app which we have installed, we can say it as user interface. So user is not having the direct access of hardware. It has to go to these channels. So if you take a picture by using our, let's say, one of the app, let's say from the Instagram, then we can't say actually user will get feel that it is saved in the hardware and whatever the image you have picked that is present in your hardware. But as soon as you click the image, then it has to go through the middleware. There is some kind of libraries which communicate with the operating system. At present situation, it is Android flavor of Linux, and which is handled properly in order to make it in the form of, let's say, JPEG image or bitmap image or whatever the format it is. And with the help of this board support package and the drivers, we will get access of actually the internal memory or the external memory, for example, SD card. And then the image will be stored in the actually hardware. However, user will not get the look and feel that actually I have saved it on the hardware and it has to go from these many processes. We have seen like what is the basic difference between the microcontroller based system and the Linux based system. We have seen the basic architecture of it, and we have seen the like how if you want to access the hardware or the hardware component actually on the Linux based interface system, how the flow goes and how the hardware is accessed to the actual user. So now let's understand what are the boards which are available, which are the Linux-based board in the market, where we can take up this board and where we can get feel of all these layers that just I have explained. So there is one SoC that is system on chip BeagleBone black board is there, which consists of ARM-based processor. Right? When I say it's processor, it's a microprocessor. It's not microcontroller. Then it will have the flash memory, RAM, peripheral input controllers, ports. It will have the debug port in order to communicate and in order to see the live commentary, what's going on in the board. And it could have the interfaces like GPIO, Ethernet, or the HDMI interface. So there is another board, it's called as Raspberry Pi board, where we can see, we can install the embedded Linux, the flavor of embedded Linux on it, and it is also having the same interfaces as that of BeagleBone black board. So let's try to understand the in general where we can find the embedded system and where you can find the Linux-based embedded system products. So you name any particular domain or the industries, there you will find the embedded devices. For example, in printing domain, the printer like office printer or the production printer, you can find the embedded system over there. The manufacturing industries, like which manufacture robot, or we can have the power plant or the machineries or the motors. This all consist of the embedded device. It will have the medical devices. If you take example of medical devices, CT scan machine, EEG machine, right? So all this consists of the embedded device. Just now we have taken an example of telecommunication where smartphone it consists of the Linux-based operating system, and we have seen it just now, right? There is now nowadays it's coming up wearable devices, for example, Google Lens. We have seen the embedded system involved in the projectors, the automatic curtain. We have seen the watch, which consists of the microcontroller based system. And nowadays, the home automation system where all the appliances of the home, that is light, TV, fridge, is controlled by using our cell phone or using some kind of Internet of Things. So which are these organizations that comes in order to develop this kind of embedded devices? So the primary organizations are Xerox, GE, we know the Samsung, Google, for home automation, ABI, Apple, Microsoft, right? So all these industries offers the embedded device in their respective domains. At present situation, if you see from 2000 to 2010, these domains where these companies, these organizations were developing the embedded device among themselves. They were not sharing this the embedded devices with the other organization. But after 2010, we can see that devices are communicating with each other. Just to give an example, using the smartphone, as I said, we can control the lights, fan, fridge, or TV. Another example is using mobile phone, we can give the print. Another example is the whatever the health of these devices, we can monitor using the Azure platform, which is owned by Microsoft, right? So the industries at present situations are communicating with each other, right? And predominantly all the data of the embedded system, which is going at present situation on the internet. So here there are, if you see this embedded products are communicating in some kind of things. So these things are might be anything. For example, this is a robot which is controlling some kind of activities in the plant, or the printer which is taking the input from the mobile phone. So this particular maze is at present situation you are observing. And this concept is called as Internet of Things, where the already developed product, which is a traditionally developed products or the new products, for example, Google-Lync, which is coming up. So already existing product or the new products are communicating with each other, and all these data can be controlled or the monitored by using the internet. So if we see the devices which communicates with each other, or the devices which communicate with some kind of things, where the limitation of microprocessor, where the limitation of microcontroller based system comes, where it needs some kind of interfaces in order to communicate with the other devices, for example, GPRS or Wi-Fi. So because of that, predominantly nowadays in the industries, wherever the product which was microcontroller based, it is getting shape of Linux based or the microprocessor based operating system based products. So here are some examples of Linux based embedded system. The Ubuntu is a predominantly used operating system in order to make it run on the Raspberry Pi or the x86 or the ARM architecture. We know well-known Android operating system, right? So it has taken it from the embedded Linux, and nowadays it is running on the smartphone. So basically, the Google has taken the basic Linux version. They have modified it. Then they have created its own APIs, and they are given the name as Android. And on top of that, all the developers are developing their mobile app, and all the companies are taking the Android operating system from them, and they are developing their own flavor, right? So these are all the different flavors of the operating system. But if you see underneath of that is the basic Linux operating system is running. Okay, we understood that difference between the Linux-based and the microcontroller-based system. We also understand that why there is a need of more engineers in this field, because nowadays the shape of microcontroller-based system has been taken to the based system. But we will understand it now that what exactly market is asking from the someone who has having the experience on the embedded Linux. The first part is we should understand what is embedded Linux. We should understand basically what is Linux operating system. There is very basic things, scripting we should know, that is shell scripting. Then we should have the understanding about the C programming. We should have understanding about the multi-threaded, some basic understanding about the multi-threaded and multi-processing programming. We should have understanding about the system programming and the Linux device driver concept. So let's look into one by one in detail how much understanding we should have in all this 5 domain. So first one is architecture of Linux operating system. So we should know in general how the Linux works and how it is different from the other operating system. Then also we should know about what are the different applications where the Linux can run. And we should have the basic understanding about the command line interfaces in order to communicate with the processor, in order to communicate with some external devices. About shell scripting, we should have the understanding about the very basic commands of the Linux and some basic understanding about the shell scripting, where we should also know some basic if-else condition, how the control flow works, and some kind of automation using some of the inbuilt tool using shell scripting. Next one is embedded C, where in general we should have very basic understanding about the variables, operator, bitwise operators, control flows, function pointers, Uh, Here, if we are not aware of data structure, it's fine, but we should understand about the what are the user-defined data types, that is structure and unions. Multi-threaded and multi-processing programming, where we should get very good understanding about how the processes and the threads are created, what is its use, how to manage it, how to communicate between the threads and the processes. A powerful library, that pthread library, is present at present situation in the Linux, that is used for the multi-threaded programming environment. That understanding we should have. We should have the very good understanding about the fork system call. So if you are a very beginner, nobody would expect that you should know the system programming and the Linux device driver. But it's good to have these skills also, where we'll get very good understanding about the bootloader and the boot file system, as well as how actually the example which I have taken initially during our presentation, that when we install the mobile app, when we take the picture from our cell phone, how it is saved in the hardware, because we don't have the operating system, or user doesn't have the direct access to the hardware. So if you understand those that flow, where you need to understand the concept of the Linux system programming and the Linux device driver. So in order to learn all these five aspects, what we should do in order to learn all these five aspects of the embedded Linux, as I said, that we should understand what is the Linux, right? So we should install the Linux OS or the virtual box in our system. That is the first step that we need to do. As soon as we install it, then you should start using the Linux terminal in order to explore your system. Just like if you do in Windows, then we actually open my computer, then we go to the drive and we see what are the movies present, what are the presentation, what are the books present, right? So we, in order to navigate through it, we should use the basic commands of the Linux terminal, right? And in order to use it more effectively, for example, if you want to rename the file, if you want to transfer it from one location to another location, right? So how to do it, you need to understand some more commands on the Linux. You can start exploring it, and you can start more on this, like in order to configure the network. For example, if you are connecting to network Windows, you just click it on the Wi-Fi signal, you just give the password and it starts running. So you can access the internet connection. Unlike, you can use the Linux terminal and you can do all the scripting or the command line argument, and you can turn off or on your network configuration. Then if you understand that, then it's very good right time to purchase your own BeagleBone Black or the Raspberry Pi board, and where you will get flavor of Linux, and you can connect into your desktop, your and your mouse, and then whatever things you have learned here, you can just try experimenting on there, and you can try to understand the basic difference between the in general OS which you have installed in your laptop, and the actually you can experience what is the difference between the OS which is there on the these boards. Next part is shell scripting. Here, after getting these details, you will get very good first level of confidence that, okay, I'm well acquainted with the Linux OS. Now let's do some kind of experiment, some kind of programming. So the shell scripting is nothing but a basic elements where you don't need to install any compiler or editor for it. By default, if you install any Linux or any flavor of Linux, by default, it comes with the shells editor as well as compiler. So here you can do some kind of stuff in order to automate using the shell scripting. Right. And the same thing you can try it on the BeagleBone and the Raspberry Pi board. You can start learning the C programming. Of course, you don't need the Windows Linux environment in order to learn it. But if you start executing the code in the Linux environment, start debugging it, then you will get very used with the Linux-based environment. After learning this, you can simply run you can simply compile one C hello world code in your Linux system, which is there on your laptop, and you can put the exe on the BeagleBone on the Raspberry Pi board, and you can see whether it will work or not. You can try what's problem you will get it in order to run the code, in order to run the exe which we compiled on the your Linux based board. Right. So this cross compilation you can learn. Then you can start with interfacing the LEDs, motors, which and you can start controlling it by using the C programming in order to get more insight on. After completing this C programming and controlling some kind of external devices, for example, LED switch or the motor, then in order to get more insight on the multi-threaded and multiprocessing environment, you can convert all the C code which you have implemented earlier in the multi-threaded or multiprocessing environment, where you can just connect one LED in order to monitor. We can create one process in order to monitor LED. You can create another process in order to monitor the motor, or you can create the another process or thread in order to get input from the switch. This much of workaround, then it's time to understand internal. Up till now, we were just user to Linux, if you understand it, right? So here we were just installed the Linux, and then we have just used already existing thing. Here also we have used the C compiler, and here also we have just used some kind of libraries which is already existing. Now it's time to deep dive into the Linux kernel, and in order to, we need to understand how its system is built. So you can use the Acto build system, and you can create your own flavor of. In this way, you can understand how the booting process works. You can you can select while Acto build system which bootloader you need to use. To conclude, that at present situation, if you see a typical job description, any a person who is having the 0 years of experience, or let's say some experience in the startup where you are working on some other system or altogether in other domain, and you have the very basic understanding about the one of these skills, or you don't have the at all experience in the one of the skill set which I have explained during the presentation, but the job description says, job requirement says, candidate must have the experience in C, shell scripting, basic understanding about the Linux, basic understanding about the system called the multi-threaded and multiprocessor program. All right. So the path I explained you will give you direction in order to learn, in order to enhance your skills, to be a very fulfill for this job requirement. So you can learn the basic concepts of the Linux system first. And as I explained during the flow of my presentation, that you can implement the mini project on the Raspberry Pi or the BeagleBone Blackboard using the flow which I have explained just now. That's it from my side. Thank you.